you can do is try to design your software in a way that things that could be errors are designed so that they not necessarily are errors, but you handle them in the same way as other parts of your code. An example here might be, instead of saying throwing an exception, you return basically a result type. And so this is something where it's either a success or a failure, instead of just kind of having to fail and having a whole different mechanism for how to handle that. And so if you start kind of building things around that, then it makes it a little bit easier to track the code, the logic in that code. And then the final point here, well, moved off, let's go. Sure. Is the full complexity downwards. And this effectively means that the farther away the complexity is from what you're working with in general, the better. Software design topic. In general, base idea is it's defining the specification and the structure of a program from a high level overview. And so the key idea here is this is like the API versus implementation. So your API is like your application programming interface. So it's the stuff that tells you what the code does and not the stuff that is actually doing the work of the code. Because the implementation we don't really care about from a design perspective. We just want to understand how the different pieces and parts fit together. So a couple key elements. One is various concepts. For anyone who's kind of seen like object-oriented stuff in the classroom environment, you've probably seen some of these things. So abstraction, encapsulation being some of the main tenets of object-oriented programming. Then being modularity, which is basically how are things broken up and split into modules that are easily understood. And so obviously the kind of better you do things like this, in theory, the better software design you'll have. Various other goals, maintainability, kind of one of the main things that you're looking for in good software design. Extensibility, simple idea is how easy can you change the software to add new features and new functionality. And then security as well, in a sense. If you have good software design, you have much less to worry about from a security perspective too, in general. Then lastly, there's design patterns. So this is just kind of like reusable solutions to kind of common problems. Things like builder factors built in. You might study these in a class or not, as much, but you will learn them, particularly across languages. And so it can be very helpful to kind of understand what those patterns are, because then when you'll see them, you'll have a pretty good idea of what that part of the software does. So the more kind of larger scale software that you work with, the more you'll probably see things like this being used. Okay, so quick question. To what extent does a programming language affect software design? So anyone, so Anna brought an answer. Yeah, sure, go ahead. A lot. Go ahead, yeah. So to a large extent. All right, so does anyone think it doesn't really affect software design? Yeah, yeah, why might? Yeah. Good. Yeah.
Which is like super esoteric. I mean, but the different programming languages can like follow very similar logic.
Yeah, so similar languages probably have similar design, is what you're saying?
Yeah, so like there's not like too much of a difference.
So say one or two more, yeah.
Issues might not be uploaded on my site, for example.
Yeah, so harder to find problems and figure out like the right way to do things. Yeah, all right, like one last one. And yeah. Yeah, so IO points of things. What says kind of hits on the key idea, which is yes, the programming language does matter. But another way I might say is that like the type or the style of the language matters much more than say the particular language. Some languages are very similar. So some languages have different themes that are kind of between them. So JavaScript and Python are relatively different languages. But they both have object-oriented like capabilities, as well as they both don't really have types. So similarities between those languages are much more than say Python and C, or something like Java and everyone's favorite crazy language Haskell. right? So depending on what language you're working in, some things will be similar to others, but at the same time, the language does kind of have a noticeable impact. So I guess ultimately no right answer, but depends on the language. Okay, so we're going to talk about the main idea of this presentation, which is design by contract. And this is basically an idea where software has a contract between the client or someone who uses the software and the supplier, which is basically the implementation. And it's something like functions, right? So when I call a function, I am the client. I call the function, I use that function, and whoever implements that function has a responsibility to basically implement that function correctly, right? And so they do all the implementation stuff and give me the result back. So the details of that look like this. The client must meet all preconditions. So this means if I call a function and the function says, hey, you need to pass me arguments like, just say like the name of a person. If you don't give me the name of a person, I'm not going to work, right? So you have to start everything off by giving me the right input that I need. Or for more object-oriented style things, you might need to call me in a particular state, right? So if I'm like storing a file or something and that file isn't open, then you might not be able to read values from that file because you have to open the file first, right? So there's things like that. These are all preconditions. And the supplier, basically, this is a fancy way of saying that if you do all the preconditions correctly, then the supplier basically has to do the implementation correctly, right? So effectively, all of the precondition stuff. So yeah, the file's open, I have access to it, I have a name of a person, whatever. Then do what the function does and return the result. And that should work, right? In practice, sometimes it doesn't, but it should, and that's kind of the specification. And so both sides can assume that the others meet their part of the contract, and they can verify it as needed. So this is basically saying that if I'm implementing a function, then I can expect that the user gives me the correct, data or is calling things in the correct state or whatever. You can verify that, and a lot of the time it is good to verify that. But verifying that all the time could be a little bit of a mess, right? So oftentimes, like in statically typed languages, we have types of the parameters, and that generally does a pretty good job of things. But it's not the only type of precondition. So a quick example, just to kind of give some concreteness to this. Square root function, right? So standard square root function takes an integer number, returns an integer. So general question, what might the contract of this be? So we have two parts of the contract. One is the precondition and the other is the postcondition. So let's start with the precondition. What might the contract of this be? Yeah. Right, so they have to give us a number, right? So who verifies this precondition? User. So the user does, but there's another thing at play here too. And a bit of a trick question. So it is a signed integer, right? So I'm kind of basing this off Java. So int would be signed. So the thing I'm saying is that what verifies an integer is passed in here, at least in Java land, is the compiler too, right? The compiler will verify that you give this an argument, and if it doesn't, then it'll fail there. So we actually don't have to worry about that from our implementation side, or in a sense the user side, because that's being checked for us already. What other precondition do we have? There's one other thing. Yeah. Positive number. Anyone from the streets want to respond to that? It's 0 a positive number. Yeah. There we go. All right. Let's get instructions everyone. Everyone's favorite class. Okay. So 0 would be okay, it takes square root of square root of 0, so 0. So we can say, a negative number, or it cannot be negative. And so this is a primary precondition here, right? It needs to be greater than or equal to 0. What's our post condition? Yeah. Right. So we have to return a number to the user that's accurate, right? And so one thing we might do is we might look at something like this, or there's an implementation. And so we can kind of say that if we square the result, then it's basically less than or equal to the number. And the square of the result plus 1 has to be greater than number. This is a bunch of fancy math stuff to basically get across the idea that because these are integer numbers, we can't take the square root of an integer without doing something else, right? So we can't, we're returning an integer. So we have to basically floor the result. Now, there are other ways. We could define this another way to say instead of an integer, it returns, say, a decimal number, right? That's a perfectly valid thing to do. But for the signature we have, right, where this returns an int, then you get something like this. So you can see, so even something relatively simple like a square root can get some pretty funky preconditions and postconditions onto them. So it's very helpful to track that. In addition, what would happen if we changed our integers here to doubles? How did that affect the contract? Yeah, go ahead. So user could give a larger number, right? So hopefully our large numbers are okay. We can't get that large, but yeah. So we have decimal values, yeah. So one thing, for instance, so our precondition stays the same, right? The number has to be greater than or equal to 0. Anything with post condition? Yeah.
Like really close to the square that will get the input, right there.
Right. So instead of having something like the above, we have to do this weird range thing check. We have something where the result is very close. But as you pointed out, because of the imprecision of decimal numbers in computers, we're going to get something that may not be exactly correct. Right. Then we can encode that in other complex ways, but that's not the point here. The other really last thing is everyone's fun chaos about floating point numbers. There is infinity. Infinity is a valid input, as is negative infinity. So have fun with that. And then of course, name or not a number is an option as well. So good times. Don't write contracts for that. All right. So we're going to do a quick another kind of try thing. And this is basically for an account. So we have some type of account, like just a simple bank account or whatever else. And we have a balance, which in this case is decimal number. And then we have some function here called deposit, where we have a double amount. Okay. So what do we think our preconditions and postconditions here should be? So we're running out of time. Let's do preconditions first. So precondition, what should happen to call this function? Yeah.
So give a positive decimal value. You can really deposit 0, so it's not going to be non-negative. On top of that, it could be NAND, it could be positive infinity or negative infinity.
Yeah, deposit infinity. Man, I would like that. So giving a positive number here is good. Is there any harm in allowing you to deposit 0? Not necessarily, but is there any benefit to it? Probably not. So that's one for simplicity, you might allow it. But in general, probably a good thing to disallow that because you never know quite what could happen. Particularly if you're in a real bank system and this is like transactions between accounts and other stuff like that. So better not to try to worry about that. Okay, what is the post condition? So first, what does this function return? Yeah. Right. Right. So this function doesn't return anything, but our post condition is something that applies to the actual class instance itself. Right. In this case, we're checking to see that depositing some amount actually affected the balance. Right. And it did so correctly. Now, one thing we could do is if we wanted to kind of look at alternative designs, we could have something like a deposit function that does allow negative numbers. Right. And we could say that's basically the equivalent of withdrawing things. Yeah, it's probably better for the same reason as preventing 0 to have a separate withdraw method. Both are technically correct, and that just comes down to software design, right? What's the best way to avoid unintentional issues with how other people are trying to use these methods? Cool. Final note, don't use floating points of money. Yeah.
That way, it's more having a dual video. So how do you balance deciding to do that versus deciding if we can have like in your content or how it's clear problem?
So that's a different too. The short answer is what you're primarily looking for is kind of like the larger scale of what the context of this thing being used is, right? And what are the consequences for it being wrong? So if you wanted to have a simple kind of like modified balance type of thing, you could do that. But it's not going to be like as encapsulated as something that manages this account. The other thing is that you're going to have layers of kind of in a real banking system, you'll probably have layers of transactions, right? Where, you would basically try to remove things from one user, send them to another, or whatever else is going on in the system. So to that extent, I would generally lean toward having something like more of this, where it's validating those conditions. Because the code that you're going to do, depending on whether you're depositing money or withdrawing money, is probably going to be different. So, but what you said is perfectly valid, right? You can do the same type of thing by just simply having, a change balance by some, delta amount or whatever, right? And that would be a perfectly okay thing to do too. It just depends on the grander scheme of things. So that might be a case where I differ a little bit, and I think being more explicit about those errors could be good. But yeah, depends on the context. Yeah. Yeah, I was going to talk on this, Rick Sec, yeah, question. So the note here is don't use floating points for money. Numbers in computers aren't precise, right? So decimal numbers going to have like wishy-washy decimals at the end of it. So the end result is that if your balance gets too big, you're just going to start losing precision. And so this gets into like office space style, theft, where you basically siphon off decimal points of money and things like that, or like rounding errors accumulates and stuff. So like, I don't know about your guys' bank account, for mine, this is going to make a difference. But like someone who has like a lot of funds is going to start seeing rounding things that are like the tens of thousands of dollars if you start getting high enough numbers. So yeah.
Deposited 3 cents to your account twice and then subtracted 2 cents 3 times. If you were to run that forever, eventually like those small bits would just keep counting up forever and you eventually have like infinite money.
Infinite money, it sounds good. Yeah.
So what would be a more ideal way to store money? You just store it like integers and integers represent the
Yeah, different styles. Using an integer for the number of cents is a pretty common approach. So many languages will also support something called a big integer, or some type of arbitrary precision integer. Some languages have this by default too, like your default integer is just going to be arbitrary precision, so you can add to it whatever. So in general, storing an integer number of cents is a pretty good approach, and then you can have arbitrary precision on top of that. Likewise, you can use like a big decimal if you want to store the actual cent value, but it's kind of two separate problems, right? One is the precision of the number per se, and then the other is does it have an upper limit or not. So yeah. Okay, cool. I think it's time for okay. First off, we're going to find the error in this code. So I have this little main function. This is normal Java code, for the most part. Arrays.list is a normal function you can use. And this basically just builds a list that is 1, 2, 3. And it prints the last element of this list. I have a get last element function. We'll see that in a second. It's not important at the moment. So first off, what should this print? 3, right? 3 is the last element of our list, so we're expecting it to do that. However, it doesn't do that. It does a little something else, as we'll see. Here's our get last element function, right? So let's take a quick look at this. Does this function make sense? Right? Does this look like it does the right thing? Yes. Okay, so with the addition of some various key stuff from Java, the key idea is that we get the elements at the index of the size of the list minus 1, right? And that's our off by 1 errors because things are 0 indexed. So if the size of the list is 3, we get at index 2, and that should be the last element, right? So this makes sense. Right? Yeah. This is called generics. Basically, it's saying that I have a list of some type, and that type is T. And so whatever list I pass in, regardless of whatever type it is, it returns an element of the same type that's in the list. So in this case, I'm passing in a list of strings, and so I'm getting an element that is a string out. If I were to pass in, say, like a list of numbers, I would get a number out. If I gave it, a list of complex objects, I get a complex object out. So that's what it does. Okay, so I ran this, it didn't work, right? Right. So when I ran this, it threw an error that the index is out of bounds. Okay, that's a weird one. Let's take a look. So what did I do? Well, I went ahead and I tried to assert that the list is not empty. Right? If the list is empty, then get size is going to be 0. And it's going to subtract 1, and it'll come back at -1. Right? So I guess the last element is fine as far as the last element goes, but the point where it was wrong is that you could still pass in an empty list. Right? And this is the point where we can use something like assertions to basically validate those preconditions and make sure the user is doing the right thing. Right? That way we can at least fail predictably and with like an error message that properly says list cannot be empty. Make sense? Okay. So I ran this a couple more times, and then this happened. Exception to code named array index out of bounds exception -1. Oh damn. Like, I don't know. Like, I'm asserting the list is not empty, so obviously, right? It has some elements, and then it apparently doesn't. That's really weird. Okay, so lessons on how to debug things that make zero sense. First thing, what's a key weird thing about my assertion versus the implementation? Yeah. Using size, right? So I probably want to check to see if the size of the list is actually, greater than 0. List empty should do the exact same thing, right? So they should be equivalent. Question is, what happens if they're not? I create a new list where the size is always 0. Yes, you can do this in Java. Yes, it works exactly as I said. This falls into your preconditions and postconditions thing, right? The general idea is I built a class here where I'm overriding a function, and the contract of that function says that I need to return the size of the list, right? But I've broken that postcondition by always returning 0, right? So this is a case where I have implemented this incorrectly, right? So if this was in my code, this is my problem that I need to fix because I didn't follow the contract of what array list says. So unfortunately, this can happen in other people's code too. Yeah, that is not an easy solution. Then you need to go bug people about it. So what's the point of that example, right? How many people maliciously create this list and pass it around, right? What's the point? Yeah. All right, thanks. So there you go. That's your reason why, because people are out there who just do things to mess with you. But there's a bunch of reasons here. One is to kind of point out some of the debugging things. One is to address kind of how contracts work in practice. And the other thing is to express why this type of problem is super important and very bad. Look at this exception. Another single point in this to actually see that the class is not an array list or a standard list type, but it's actually this custom MyList class on the next slide, right? MyList. Over here, this all comes from array list, right? So you would never be able to find out that there's this other class in here just by looking at this error, right? This is something you'd have to be able to replicate and then dig into a lot further, and that can be really tricky to do. So that's the reason why these types of preconditions and postconditions are important. It's worth keeping an eye on in all the types of code that you write. Yeah, you can zoom through all the animations there. So to run things out, let's talk quickly on next steps. First, go develop some software, right? Get some practice. I recommend trying to pick like a feasible, interesting project. And then the important thing there is to actually see it through. A good chunk of the learning experience comes not from like the first, 80% of the project or so, where, you're figuring things out, you're learning things a bit, but you're kind of going through everything. A good part comes from that last 20% where you start realizing what you did in the first half that was wrong, right? And that's the point where you realize, oh, I designed this system and this system, and they don't really fit together in the right way. And so you have to go back and tweak it. And that's the point where you start figuring out the software design piece, right? How do all these things interact? What things were good decisions? What things were, maybe not so good decisions, and how it all works through. Next, software design patterns. Definitely, if you haven't seen them before, they're worth taking a look at. Some details there, but they're not too critical. But as you do more stuff, you'll kind of pick them up and see them around. So worth being familiar with. And then finally, and probably one of the most important, is to experiment with different languages, frameworks, tools, technologies, other things like that. So one example is object-oriented languages versus functional languages, or things like Angular, React, Vue, Ever. And in general, you're trying to answer yourself the question, why or how are these similar? Why or how are they different? And when do those differences matter, right? You're trying to kind of build a mental model of, what is the important things about this framework or this other framework, and why do they do this in some ways, and which is better? And in those certain scenarios, one is better than the other. And kind of getting like that type of understanding of things is really going to help in the software design space, and is really going to help in just software as a whole. So as one kind of suggestion or challenge of having it, next project, kind of try to pick like one file, one function, whatever, feasible unit of work. So one line might be it better be a really good line. But try to pick just like one, small piece of things. Doesn't have to be the whole project, but one piece, and just make it as good as you can. Right? Do the steps, make it, good code style, but do like the documentation stuff as well. Right? And take a look at it from a product design perspective. Does this piece make sense? Could I have designed this better? And it's that type of practice that you'll kind of need to, try over and over and over again and kind of learn through things. Another general fun tip, design things as if you're building it for another developer to use. Working on libraries and other stuff like that, that's kind of a good tip I have, because that'll really help you see whether things are, good design. And most of the time, you're really building things for developers to use. So here you go. Okay. So yeah, go ahead. I do. Short answer is reinventing the wheel is a terrible idea to do everything except learn about wheels, right? If your goal is to learn about wheels, it's great. So for instance, like my little mini hobby is programming languages. So I like learning about programming languages. So I will build programming languages, right? Similarly, building compilers or parsers for languages or whatever else. But if, your goal is not to learn about programming languages, doing all that type of stuff probably isn't going to help too much, right? So it's kind of like, unless your goal is like learn how to build a web framework, right? Use one out of the box and recreate your own type of thing. That's in general what I would say. And then it comes down to what is your feasible scope of that project and how much time do you want to spend on things? Because it's very easy to get sidetracked into, it was this little thing and this little thing and this little thing. Hand-rolling things can be dangerous, but at the same time, too many dependencies also may not be good as well. So finding a balance is no easy right answer. So yeah. So at the very beginning, is a very last start here. So I have food for thought on which of these is the priority, right? Correctness, performance, maintainability. Does anyone kind of weigh in here? What are some people's thoughts? So let's start with this. So largest priority. Who thinks correctness is the largest priority? It is 50%. Who thinks performance is the largest priority? Okay, couple. Who thinks maintainability? Okay, so it's about a 50-50 split between correctness and maintainability. Okay, so performance, I think we can kind of agree probably isn't the priority. Correctness and maintainability are a bit more interesting. Someone who said correctness is the priority. Someone tell me why. Yeah. Yes. I mean, an empty program is, has no bugs. It's beautiful. So aren't you the one who posted that? Oh, okay, someone did. Something. Someone on the maintainability side, right? Yeah. Okay.
It was for an IT company. I was writing a dashboard, and it was making API calls to an external API, which is where they manage their tickets from. And so what happened was an intern wrote this dashboard and then left. So there was nobody working on this dashboard. They came into work one day, and the command line just spat out error after error over and over again. And so what actually was wrong was that the API token that they were giving to this external API went invalid. And they had no idea of knowing that or catching any of those errors. And it took me literally 2 weeks to just go in there and get it back to where it was. So correctness can be fixed, but maintainability takes a lot more, in my opinion.
It's a big line. Correctness can be fixed, but maintainability is a lot longer. Yeah, so this is kind of my answer, right? Maintainability, kind of correctness. And the main reason is kind of I said, software is constantly changing, right? As your business or whatever you're doing kind of evolves, you're going to change what you're doing for any particular piece of software, right? So right now it might just be a simple thing that hooks like these two pieces together, but then it gets a new feature and a new feature and a new feature. And so the definition of what's correct for that software is changing, right? And so, as you start working on like more products and other stuff, particularly, a lot of class stuff, you write it, throw it away. Sure, correctness is the priority because no one's coming back to it. But for a lot of the stuff that you work on in industry, maintainability is probably going to take priority. Or I should say, it should take priority, but it tends not to. Is because if you get to such a point where you hit that bottleneck, then you're not going to be able to do anything to actually release new features or fix bugs or anything without spending a ridiculous amount of time. And at that point, you're just going to be a constant battle to get to the point of correctness. And so you're never going to be able to catch up to it because you can't work on your software fast enough. Yeah. Okay, so very last thing, any questions? We're pretty much right at time. So good. Anyone have any last questions? Is that that's not a question, that's a picture. Okay. I guess the question is, can you take a picture? Yes, you can take a picture. Okay. Well, I'll pass it over to Trevor here in the background.
We're gonna pick that up to this, or can we do something silly? We can do something. Okay, yeah. Like a game. Okay, yeah. See. There we go. Thank you, Blake. That was incredible. So we have a lot in store for this semester. Next week, what? Oh, that's fine. Still see it, but next week we have it's dark SSD dark theme. So Jonas and Michael are going to give you guys a workshop into Golang. It's going to be a little more hands-on next week. And then at Swamp Hacks, that following weekend, we're going to give an intro to Git. So it's sort of going to be like an unofficial club meeting, but the idea is that the Tuesday after that, we'll be able to give an advanced Git workshop. So if you've been to our Git workshop in the past, you probably won't need to go to the Git workshop at Swamp Hacks, which is during the weekend. But if you haven't been to our Intro to Git workshop from last semester, I would highly recommend, well, you all should go to Swamp Hacks, but also go to our seminar on that. We found, a social game night, something like that. We usually play Minecraft or Smash, something like that. The week after, we have a speaker from Go Guardian coming, and he's going to give you guys a talk on either gRPC or on resumes or both. Haven't figured that out yet. Then our meeting on front end, the first one is hopefully going to be enough to give you guys enough, understanding of HTML and CSS to be able to go out and build your own website. And then the following week, our club member Brian is going to give you guys additional, basically kind of continuation on that, where we're going to talk more about JS and like more functionality, stuff like that. Then I am going to give you guys a really simple tool that you can use to make a backend with Python and API. Something that I actually learned when I worked at Verizon. And then everything else is sort of up in the air. Robos is this really cool programming language that's up and coming. It's going to absolutely blow the industry away. So can't wait to present to you guys on that. But so yeah, like mentioned earlier, this Saturday we have our hackathon. It's not in Darwin. This is a lie, but we will announce, of course, where it will be once we figure it out. And then, of course, next Tuesday is our seminar in the Go programming language. So yeah, and that's pretty much it. Thank you all for coming.
So if you guys have to leave, you can go ahead and do that, but I'd like to close it out with something that's a little more fun. So I'd like you guys to kind of get into groups of 4 or 5. We'll help you find groups. And then after that, choose a character from a movie and write a monologue about that. That'll take about 60 seconds to do. Then one of your members will come up to give the monologue and everybody else will try to guess who it is. So go ahead and leave, but otherwise get in your groups.
Yes. Girls are probably going to grab dinner too. So if you guys want to stay around longer and grab dinner, we'll probably do that. Usually what we do, but yeah. Huh? Well, I think they heard me. Most of them did. It's good enough. Thank you, everyone in Zoom who came.